right. Hi. Hi. I see many of you people standing and sitting on the stairs. Please raise your hand if there's a seat next to you that is still free, that is still vacant. Please do, because I see here and there are some seats. Nobody? You smell bad, I guess? No. All right. Welcome. First of all, a question to you all. Who do you thought was presenting here? I'm not Venkat. I'm not Bert Sutter, who's in the other room. Sander Mack is over there. I'm Brian. Hi. Today we're going to talk about common mistakes in functional Java. So if you're here for that, you're in the right place. Awesome. If you see this guy over here, what do you think? Kind of weird, right? To drive a motorcycle like that. And let me first tell you a story. We developers tend to work like little children. I mean, if I give my little cousin a new toy, he will take it everywhere. He will take it with him in bed. He wants to go to kindergarten with it. He wants to take it into the shower, to toilet, whatever. And the same type of behavior we developers have. I mean, if we have a brand new, sparkly new toy, code construction or whatever, we want to solve things with that. It doesn't mean it's the right way to use it, though. I mean, you can use it, but is it the intended way that you should use it? I mean, see this guy over here. He's driving a motorcycle. This way of driving a motorcycle can get you from point A to point B, right? But it's perhaps not the most efficient way to do so. Are there any people in the room here who drive a motorcycle? A lot. So I'm still wondering, how does this guy shift gears? Right? For the people who do not drive motorcycles, you shift gear with your foot. Would be pretty impossible. You look only first gear and like, So you can do this, but it doesn't mean you have to do it this way, or it's not intended to do this way. And we developers do the same thing. I mean, you know that saying that when you have a hammer, everything looks like a nail? I mean, it can work though. And we have this other saying like, hey, come on, it works, right? And if it looks stupid but it works, it is still stupid, right? You see, I mean, perhaps you can convince your product owners and the business people that it works, and it's fine. But I work with colleagues, and I try to love my colleagues, or at least make sure they not kill me overnight. So things like, trust me, I'm an engineer, probably work with the guys that do the business kind of things. But if you want to work and keep having a good relationship with your coworkers, no. Trust me, I'm an engineer, doesn't always work. But first let me introduce myself, because I'm not Venkat. I'm Brian. I work for a small company called Blue for IT, which is a small consultancy company in the Netherlands, and we work project-based for the top 100 major companies in Holland, most of. I'm associated with the Utrecht jug, with a nice little Duke over there. I've got stickers if you like it. So come over afterwards, I've got stickers. And with the NL jug, so big shout out to these guys. And some of them are here, awesome. So let me get started with the first mistake of the common mistakes I will tell you. And the first mistake is doing too much in a single lambda. Well, first of all, let me get back to the basics. What is a lambda? I just copy-pasted from Wikipedia, so not me. So a lambda expression is a function definition that is not bound to an identifier. Anonymous functions are often arguments being passed to a higher order function or used to construct the result of a higher order function. All right, but what does that mean to me in Java? Well, we can consider lambdas kind of like anonymous inner functions. It's not exactly the same, but you can treat them like that. It satisfies the functional interface, and you can write them in two different ways. You've got an input, the function arrow, and an output, or you have an input, a function arrow, and a complete function body. a small example. In red, you will see a higher order function. A pretty silly one, of course, because it doesn't do anything except printing. But it's a higher order function because it accepts a function as a parameter. It is called over here with an inline lambda. A lambda, a function as a parameter. I mean, this is quite readable, right? You can do this inline with a single line lambda. Nothing's wrong with that. But can you imagine if you want to do more in a single lambda like that, and you want to add more functionality with it, and perhaps do an if-else statement in it, or a try and catch, and your lambda ends up like this? Would you still use it in line? And if not, doesn't that defeat the purpose of a lambda? I mean, if you do it like this, and you write it in line for your as a parameter to your higher order function, I think your code will be less readable than more readable. And what we're trying to do with functional programming or declarative programming is to make sure that your code is more readable. So say you want to do more in a single lambda. You need to add functionality to that piece of code. Well, we have this thing in Java called a method. It's been there for a while. And we can refactor it simply by making a private method and actually calling that method inside your function as, in this case, a method reference or as an ordinary lambda. And I requote Venkat in this one, use your lambda as glue functions, not just to store all kinds of crap in it, but make them concise and readable. This one was pretty obvious, right? Let's go to the next one. The next one is returning a stream. And again, back to the basics. What is a stream? Now, a stream is not a data structure. And second most important thing is that a stream is not a data structure. So, okay, it's not a data structure. What is it? A stream is something intermediate. It's something that is derived from, say, a collection. And you can use it as your work copy, let's say it like that. You can create pipelines of functions in that stream, and they will be lazily evaluated throughout the pipeline. So, intermediate result, lazy evaluations, and normally in a stream you can transform data, but you cannot mutate data. But I guess you already knew that. Simple example of a stream is like this. We want to iterate over a list. We supply a map function. And we see that we have two different kinds of functions. The intermediate functions, and these intermediate functions give you back a stream, and the terminal functions. These terminal functions turn it into something that is actually useful. Keep these two in mind. Because when you return a stream is not a data structure, I said. We can only use a stream once. If I declare a stream like over here, and you see the stream beer stream is beers.stream, not pretty fancy, and we consume the stream with a terminal function for each, we can do this once. But if you do it twice, you will get an illegal state exception. And that behavior is different from normal collections, right? You can do it over and over and over again. So you should not reuse a stream. I mean, a stream is a single-use chain of operations, and it's never meant to be persistent. To persist it over here inside an instance variable, in my opinion, is an indication that you misunderstand the concept of it. Furthermore, if we go through that, be careful with returning a stream. I mean, a stream can only be consumed once. And if I get a stream inside my function, I publish it, how does the user of that function know if that stream is already consumed or not? It doesn't, and you cannot check it. I mean, for an optional or something, you can check if it's empty or not, but for a stream, it's not possible. So, should you give back a stream or not? Well, you can, of course, and returning a stream is perfectly fine when you write your private intermediate transformers for your stream. No problem. If you create a stream every time that function is called, say list.stream, it's perfectly fine. When your result is very, very, very large, and like perhaps infinite, or doesn't fit in memory quite well, you can return a stream. But by default, I would say return a collection. Of course, this one is debatable, because if you read the book by Joshua Block, he says to return a collection. If you read the post by, say, Brian Guts and Stuart Marks, they will say go default by stream. But I would say return a collection, because everybody knows what they have. Everybody knows what they can do with a collection. You can iterate over a collection, and you should not do anything more. Moreover, I think it's more consistent. But first and foremost, be careful with returning a stream, and do not consume it twice. I'm talking about consuming a stream, but you can also forget to consume a stream. That's our third mistake. So back to that stream kind of thing, right? Say, yes, this is my drawing. Awesome, right? Say we have a collection. That's the bucket on top. And then we have our pipeline of functions. Say the first one is a map function, the second one is a filter function. Okay, now I execute my code. It doesn't do anything. Why? Because it has no purpose. It doesn't do anything because we do not terminate the stream. We do not ask it to turn it back into a list, a collection. We do not reduce it into something. It's still a stream. And streams, by nature, are lazy, like me. So we put in a collector, or a reducer, in this case a box. And when we call it now, it will actually do something. Take a look at the following piece of code. On top, I have my list of beers. And yes, it are not only Dutch beers. I put in one Belgian beer, just for the sake of argument. And I do some operations on the stream I just created. Does anybody know what will happen? I executed this morning, and I'm still waiting for output. Because it doesn't do anything. I mean, looks cool, and you perhaps think that if we iterate over that list, it will throw a runtime exception when you hit the second beer because it's over 9%. But it doesn't do anything, because peak is an intermediate function. What we should do is terminate it with, for instance, a ForEach. If you do not do this and you call that function, it doesn't do anything. It just keeps waiting like this. No. So what you see over here is that, first of all, you need to terminate your stream. You need to consume it in order to let it do something. And the second is, you have to be careful with peak, because peak is a nasty one. Peak is a function that passes through the stream as is, and can do side effects on it. So it's very dangerous, because normally you would say for each we will print it, but because of the side effect in this nasty block kind of lambda, we return a runtime exception at the second beer. Using peak is dangerous. Only use it for debug reasons. You can use it to insert a peak inside your stream to print out how it evolves over time. So if you want to iterate over it, what does it in the meantime? Things like this, please do not. If one of your colleagues does this, please shoot him. No, in lag, so he can correct himself, right? No, but please make sure that you do not do that. Next one. Mutable objects. Then we come in a whole other discussion. Okay, let's get back to functional programming. What is functional programming? Because purists will say Java is not functional programming, and that's true, but we do functional style of programming at the very least. Again, I copied this from Wikipedia because I'm very good in copy pasting. And you see that a few words are important in this definition, right? functions, avoid changing state and mutable data, declarative programming, and expressions. Well, think about mutable data. What do you do with mutable data? You change state, right? And if you do that over and over again, you have to keep some sort of mental mind map in your head what a function will do in a certain state of that object. If your object is not mutable, it's quite easy, because things go in, something will happen, things go out. Every time you will do that, the result will be the same. And if I can quote one of my favorite scientists, Albert Einstein, he said, insanity is doing the same things over and over again and expecting different results. I think he didn't work with mutable objects. Because if you work with mutable objects, an object can be in different states, and I have no clue anymore what it does. Moreover, if you use mutable objects, it is very hard to parallelize things. If you use immutable objects, it will be far more easier. And I mean, a function should be like a question, right? And a question should not change the answer, nor should asking it twice. So if we keep our objects immutable, our functions will be like asking questions. So it will be kind of pure functions, which makes everything a lot more easier. And I know this is not always possible because of frameworks, because we actually need to with projects we worked on. But try to avoid changing state. Because less moving parts, it's easier to reason about code. And I know when you write code, it's probably easier to change state of that object. But think of the poor souls who need to refactor or need to read your code, like in 5 years from now. He has to keep track of what's happening and what does the object do, etc., etc. So less moving parts, easier to debug. So they say that in a stream we cannot mutate data, right? And let me just show you a little bit of code, because I love that. All right. Say, for instance, this is readable, right? Somebody who cannot read it? Awesome. So, for instance, I want to map the function, say I have a beer. It doesn't work. But what's the problem? No instance variables exist, so the void. But I can change that. Let me go into the beer object. And let me do this. So instead of just setting the name, I'm setting the name and returning itself. Hey, and now it's fine. So let me run this code. And you see that for both the new collection and the old collection, the names did change. So when you read this, you cannot mutate inside of a stream. You can. But you shouldn't, of course. I just gave a whole opinionated talk about why you shouldn't. But what should you do? Well, let me just change it to something else. And instead of returning itself, I simply return a new beer with the name and the original alcohol percentage. And by running it now over here, and instead of setting the name and transforming the object, mutating the object, I simply create a new one. And now I'm able to see the before and after state and actually compare them. All right? Let's get back to the presentation because I got more slides. So, streams should not mutate. You shouldn't, you can, but you shouldn't. Instead of that, please return a new copy. That will make things far more easier to reason about. And yes, there will be more objects. Yes, the garbage collector will have more work, but just put in some more hardware. You will find. Overusing the for each statement, that's the next one. For each, it's a terminal function on a stream. It can also be used on a list, but for a stream, it's a terminal function on a stream. And it takes a consumer. And what you can do with it, you can apply side effects on it. And that's why people tend to use the for each very, very much. It's actually nothing more than a for loop, but syntactic sugar, and we do not use an external iterator, which makes it, in my opinion, more readable. So, I have a list, I can map something over that list, and for each item I want to print it out. Very obvious one. I can do side effects on it. So that means I can set, in this case, I can set the alcohol percentage of a beer. Because it's a terminal function, I can apply side effects. It's all allowed. But what you shouldn't do is things like this. I mean, what we see over here is that you have your object, and people think like, right, functional programming, that is declarative programming, right? Saying what you want instead of how to do this. So I want to enrich my original example or my original object with more information from another data source. In this case, I want to find the ratings in service A. And then I want to enrich it even more with reviews from another service. And I really saw this type of code in some batch jobs on a job I was working on. But actually what you do, you iterate over the same list over and over and over again because it is a terminal function. Keep that in mind. By doing this in an ordinary for loop, as you normally would do, you would only iterate over the whole stack once. But because it's terminal, it's not lazy anymore. And we will go from top to bottom, and again from top to bottom, which makes the time of execution far more and far heavier than it was before. So what you should do is make sure that you don't use the for each loop in this case, but try to do it in a single loop and try to use the map function to create new objects. Yes, you will create a lot of new objects, but you will only traverse over the list once, just like I showed you before. Just a funny insight, who of you does work with Java 8? So, anyone who works in production with Java 9, 10, or 11? 3, all right. Is anyone still working with Java 7? Upgrade to Java 8. No, at least, actually upgrade even more. Because in Java 8, you have the FlatMap function. And a FlatMap flattens and maps. So if you have a list of lists, and you want to flatten that into a single list with only values, you can use the FlatMap function. But FlatMap on the inside, in Java 8, uses a for each, which means that partially your lazy evaluation will be gone. They said it will be fixed. It would be fixed in Java 10, but I didn't look it up. I know that in Java 8, FlatMap is not completely lazy. Keep that in mind. Next one, order of operations. So I've got an assignment for you. Say I have my beers, and every beer has a brewer, and every brewer comes from a country. Now I want the first 3 unique brewers' countries from the beer lab library as a comma-separated string. The question, is this correct or is this not correct? There somebody says it's not. Who agrees with him? All of you agree. Yes, it's wrong, because distinct is in the incorrect place. I distinct over the brewers, and not the brewers' country. And I mean, even in a small country as the Netherlands, we have multiple brewers. So what you should do, of course, is drop it over here. And now I will distinct over the countries. All right. But we all do proper unit testing, so we will find this out immediately, and you first do a test, so when you write this code, everything breaks, right? Yes? I see nobody nodding. You're sleeping, right? So we will find this out with proper testing. Okay. But the first thing you have to keep in mind that if a stream is lazy evaluated, it's still the stream is still evolved from top to bottom. So where the distinct and where the limit is very important. In this type, it only gives you a wrong answer. Now we can test that. That's good. But say that we do something else. We have this example. The example over here. I have an iterator. I distinct on it. I limit it, and I print it out. If I will run this, it will give me 0, 1, and it doesn't stop. And if we look at my terminal, you will see it consumes all of my CPU. Right? Okay, let's quickly turn this off. So what's the problem over here? Say this iterator gives you a 0 and a 1 and a 0 and a 1 and a 0 and a 1, and you get the point. Then it distincts. So it gives me my, okay, I got a 0, I got a 1, next 0 I already have, next 1 I already have, and it keeps on going like that. Then the limiter comes in. My first item is a 0. My second item is a 1. My third item is a, and there it goes wrong. So in this case, it doesn't only give me wrong data, it doesn't even terminate. Can you imagine, no, first let me do this. If I would do it, if I would change this one and put the limit over here, you will see that it finally terminates because this one holds me 10 items and then we distinct over it. So the order of operations is of importance. Can you imagine what will happen if we not only do this, but say, hey, it streams, one of the major selling point of Java 8 was parallelize it, we didn't test it, YOLO, ship it to production. And you see it's running. Actually, you don't see anything. But trust me, it's running. And it's getting hot in here now. It's blowing and that kind of stuff. So let me quickly turn it off. So what happens over here? Parallel, if I don't do anything, parallel uses the common fork join thread pool. Okay. And it forks the part that you can do in parallel, and at the end, it will join the parts together and give you an output. It will never join because it's stuck over here. So it will never join at the terminal function. So you will not give an intermediate, you will not see the 0 and the 1 as we did before in the single threaded version. But it will only consume CPU power, and it will only generate more heat. And please don't do this ever in production. So be careful with parallel. So the order was important. The infinite stream I showed you. So the solution, first of all, look closely to the order of operations. That prevents incorrect answers, because the order does matter. And then only use infinite streams when absolutely necessary. I mean, if I didn't use an infinite stream, like I did in the example, we would not have that problem. If you don't want to use, if you want to use a int stream, please use a stream with a range. In that case, you always know that it will terminate. From 0 to 10 will terminate at 10. So it will not infinitely keeps consuming CPU power. Same holds for the range closed. And from Java 9 and up, you can use the iterator with a predicate, which helps you also to terminate. Actually, the third one is don't use parallel, or only use parallel when absolutely needed, because you will populate your fork join thread pool, and by doing this over and over and over again, you will overpopulate that fork join thread pool, and actually things will get slower instead of faster. Optionals. Optionals is something that's also like inherited from a functional style of programming like Haskell with the maybes. But it's not absolutely necessary to use it in a functional way. You can use it with imperative style programming. What is an optional? I read somewhere that it's Java implementation of the maybe monad. Ooh. People tend to get scared when they hear the awful M word. But it's just an encapsulation. It wants to encapsulate the behavior, in this case, that something can be null, and that null value we want to prevent, right? So we just consider it a simple wrapper. If you consider it like that, it's perfectly fine. What it does, by giving you an optional, it forces you to look inside the optional if something is present or not, and then use it instead of blindly use it and fall in the problem that you will have a null pointer exception. But you can't do this. And now we have the same problem over and over again, because an optional is an object. So we can give it the value null. So we can have null pointer exceptions when we use optional. Please don't do this. Please, pretty please. If we just agree now over here that we will not ever do this, then we can use optionals as they were intended. So what we have to do, we have to unpack that optional, because if I just do a get on it, I can have the no such element exception because it can be empty. Obvious. So, all right. Then I do this, right? This is what you see a lot. But can anybody please explain me how this is better than your average null check you did before in Java 7 and 6 and 5? It isn't. We have another problem and we solve it with the same solution we already had. So in that case, if you want to use optionals like this, don't use it, because it's not intended to be used like this. What you should use are the functions that are applied or that are shipped with optional, like if present, we can do something, or we can use the map function. And if present and map will only execute if the optional is filled with something useful and it's not empty. All right, that's good, but what if an optional is empty? What else? So let me get to this optional. We see an optional string over here, and this time it is filled with foo, right? We map a function run if exists on it, or else throw. That's one of the options we have. It's pretty obvious. If it runs, it will run this function. Cool, hey, it runs. But say, for instance, it is empty, and we run it again. It will give me an exception. Well, yoo-hoo, fine. But I don't want to just throw an exception if it's empty. I want to do something else. So what I do is, I delete this line, and I say, hey, nice one. Okay, and I want to do a function over here, so I duplicate this function, run if empty. It doesn't give me anything because there's nothing in it. Only run if optional is empty, and we return the string empty. And I will now oh, it must be a string, of course. And now I will return, I will call the run if empty over here. Seems legit. So if I see this code just in a glance, I will say, cool, optional is filled, so finally this one will have the value of foo. Let me check. Hey, it works. It has the value of foo. But what do we see is that also the only run if optional is empty, which is here in the or else statement, is also evaluated. This was not what I was expecting. And I fell for this trap the first time as well. But can you imagine if you use this, like say, just hypothetical. I have a user in my database. I want to check with a certain function if the user is already there. And if it's not, I want to create it. And I do it like this. Then you finally end up with your function you want to do on the user, and you're also creating a new user, which is pretty weird because I would think that it would be short-circuited in some way. But there is another one. And there's the problem. You have to use the or else get and makes this a supplier. And yes, you would know if you would dive into the optional and you read the or else get, whatever. But we just want to use this, right? If I do it like this, we will end up with the behavior we expected. So, although or else sounds like if it's not there, then we use it, and if it's there, we do not use it, it will be evaluated every single time. And that means that we should use or else in a different way than or else get. If you want to do an alternative flow, you should use the or else get. But if you just want to supply a default value, like this, then it's perfectly fine to use the or else. So there's a difference between these two, and keep these in mind. So, we have three functions, la-di-da, or else throw. If you use the or else function, you will see that both functions, so the part inside the or else will be evaluated as well. If you want to do an alternative flow, please use the or else get. And then you will be fine. So if you want to use the or else, make sure it doesn't contain any side effects. If it's pure, then okay, you can use the or else, because it's only designed to assign a default value to your, in this case, string. If you want to do an alternative flow, please use the or else get. Exceptions. Who knows what this is? The picture over here. Yeah, again, please, harder. Yes, it's the Ariana 5 accident. It was 1996, kind of. And basically what happened was that they did a transformation from the velocity of the Ariana 5 rocket from a 46 byte long to a 16-bit signed integer. And you can imagine that in the beginning the velocity is not that big, but if it goes up and higher and higher and higher, you exceed the limits of the integer. And then something failed. And then it exploded. Moral of the story, we should handle exceptions. Exceptional situations cannot be, or not always be, like, hey, whatever, we'll see what happens. So, if we have a lambda and we want to use a function which throws a checked exception, and the isEmpty exception, of course, is a checked exception because you have to always check your beer before you drink. Doing things like this, beer do something, does not work, right? So, what can we do? Well, I love code, so let's go to my exception example. Say, for instance, I want to do this. You see my function over here randomly throws an exception, which I have to catch. I have a beer list with 3 beers, and I want to apply this useless do something function over my list. This doesn't work. And what do you see many people using? Like this. Hey, we have this thing in IntelliJ which can do perfect. Oh, wow. Let me do it like this. We're fine. Ship it. I think the first mistake was don't do too much in a single lambda, right? Oh, we can fix it. All right, then I put it over here. Perfect. Ship it. It's readable. We do the try catch in a method. Well, I should say, if you need to do something specific for this for this exception and not just wrap it into a runtime, this is probably the way to go. It's not funny, it's not nice, but it is one of the solutions. But say like I check all things on forehand, and I think, well, if there is an exception, I just wrap it into a runtime and throw it up. Who does that sometimes? Luckily, I'm not the only one. I've got an opinion on checked exceptions, and I will not give it to you, but I think you can smell the difference, like what my opinion is on that. But let's not go into that. Say, for instance, let's go back to the original one. And what we can do, if we want to do this, it like this, we can make our own functional interface. Hey, that's new. I can make a functional interface called checkfunc, because I'm tired of typing. All right, cool. And what I simply have to do is apply now I can accept a function with this interface that throws an exception. Oh. Is it apply or apply? Apply, like this. So now I can, in, say, a util file or something, I can write something like this. I want to return a function from T to R. I call it my wrap method, and I will simply insert a check function from T to R, and I call it func. Awesome. Now I only have to return a function, so I say return and I apply that function to T, and then it's always complaining like, yeah, you have to do the try and catch. Perfect, I surround it over here. Oh, that's not me. And again, I will do this into a throw new runtime. By doing this, I do not want to do over and over again, wrapping it to a runtime. So I can simply do this in my lambda, which makes my lambda a bit less readable, but still readable enough and more readable than the try and catch. This works, of course, but can somebody explain to me what the problem is here? Perhaps I can show you by running it. And again. And then you see the problem, perhaps. No, and again. Well, I'll just explain it to you. It goes every time a runtime exception is thrown, your stream stops. So if your first item goes perfectly fine through that stream, your second item throws a runtime exception, it quits. It cuts off your stream. And is that really what we want? That's the question, because maybe I want to use it and traverse over my whole list or my whole collection, and at the end make sure that I can filter out the good ones and the bad ones. I simply accept the fact that something that goes wrong is also data, because we're working with streams, and it can be infinite, or it can be a large amount. And say the second one goes wrong, I do not want that my 100, 101st, and 102nd item go wrong as well, because probably they go right, and I want to do something else with it. So what we can do is, let me simply revert this one to the original state. What we can do is use something that is not there in Java yet. That's an either function, or an either type. And an either type is a generic type, just like the optional. It can be a left or a right. Not both, just a left or a right. And you can put anything in it. The left can be a string, the right can be an integer, for instance, or any object you wish. So what you can do now is utilize this stuff to say in the left part, we do an exception, and in the right part, because right is right, we give you the correct solution. And this is a very naive implementation of an either type, just to show you the example of what an either is. And I wrote a simple lift function over here with a nasty block lambda, I know. But what it does, it applies the function, and if it works, it throws it into the right, and if it's not, it throws it into the left. That means, by using this, either dot lift, and I lift it into an either type, what we do over here, you'll see that we end up with the whole stream being consumed and printed out, and you see that my first went wrong, my second went okay, and the third went wrong as well. So now I can filter out, I only want to use the ones that I really like, so the right parts. I can do a filter on it, and I can unwrap it again, so I can have my stream back, or have my good results back. But say you want to have your bad results as well, and you want to re-implement it in something. Then this one is not very, very nice, because it gives me the exception. And I do not know what the original value was, right? Any people who programmed in Scala? So you know about the try? But I'm not a fan of try, because a try gives you, like this, only the exception or the good value. And if I want to have the exception and the original value, I cannot do that in a try, but I can do that in an either. And I will show you the function lift with value. And instead of only wrapping the exception part, or just the exception, I wrap it into a pair which gives me the exception, and the wrapper, it is just a wrapper, which gives me the exception and the original value, so I can reuse it again. By doing so, and I do it like this, you will see, in this case, everything goes perfectly right, of course, yeah, sure. You will see that I will have the exception with all its data, and I will have the original value. So I'm back in charge again of how I want to spend, how I want to work with these kind of exceptions. Do I want to ignore them? Do I want to reuse them? Do I want to do something completely different? I'm in charge, but we can evaluate the whole stream. Yep, we already talked about this. We can do it in an execution, either type, left or right. You can now write your own functions and give back a left or a right if you want to, but you can also do it like I did with the lift function. Coming back to that try, which we have in Scala. A try is like a simplified part of the either. It's not different. It's not the same type, but it has the same principles. It can be either a failure, which holds the exception, or a success. And there is a very nice implementation. Also, there's a very nice implementation of the either in a library called Favre. You can use them quite easily by simply doing this. Lift them into a try in this case. But Favre is a very large library with all sorts of nifty tools for your functional kind of work. If you only want to do exception handling, it's quite easy to write it yourself like I just wrote. So you can use Favre, and I would suggest you to check this library out because it has a lot of funny and easy functions to work with. But think about the principle of using an either type or a try if that's more convenient for you. It's a different way of thinking, a different way of working, and I guess it will be a better way of working. And that's where I conclude my presentation. My name is Brian. I work for a company called Blue for IT. If you have any questions, the time is actually up, I'm sorry. Please come over and ask me. I will be around all day and tomorrow as well. You can ping me on Twitter, and I've got stickers. So thank you for listening, thank you for attending, and hope you have a One thing more. There is this app which you can write, which you can vote. Now there's only one option, which is 5 stars, and say you were awesome or something like that. If you would do that, would be so kind, you can even get all the stickers you want over here. Thank you so much for attending. Have a great Devoxx. See you around.